Hello everyone, thanks for stopping in. Today we're going to be talking about the beginning of Chapter 8 for Math 120, and we'll start off with some definitions. The first is a polygon. A polygon is a closed figure consisting of connected straight lines. So it's a closed figure consisting of connected straight lines. The lines themselves are called sides. The sides are the lines that comprise a polygon. Those are the lines, right? We call them sides. The vertexes, or vertices for plural, a vertex is a point where two sides meet. Some people like to think of them as the corners. So let's draw some examples of polygons. The first, most easy example would be a triangle, right? We can draw a triangle, right? It has three sides and 3 vertexes, 3 vertices, right? Vertices. Vertices is the plural of vertex. Think like cactus and cacti. Triangle. We also have rectangles, right? Now rectangles, we know they have 90-degree angles for all their sides. And opposite sides are the same length, right? For rectangles, they have 4 sides. And we know opposite sides are equal. Opposite sides equal. I abbreviated there. And they have 4 vertices, right? We know some polygons already. Now, polygons can be irregular as well. These are what are known as regular polygons. They're named. My polygon can be any combination of straight lines, right? So this shape has 5 sides. This would be an irregular pentagon. So polygons don't have to be regular shapes. They can be any shape. You can get real crazy with your polygons. You could have maybe a sort of castle-like archway-looking shape, right? You can get creative with your polygons. The difference is we have regular, which are named polygons, right? They have a name. We have names for these polygons. And we have, polygons that don't necessarily have a name, right? They're just arbitrary collections of sides and vertices. So that's polygons. Now, let's look at a bunch of formulas. And now with formulas, once you know the formula for a shape, you can work with it. So we're going to introduce a whole bunch of formulas we will commonly work with. And we're going to talk about both area and perimeter. So first, the perimeter of any shape, of any polygon, of any shape, is equal to the sum of the sides. That's true for any shape. If you add up all the sides, you will get the perimeter. That's going to be true for every polygon. You can add up the sides to get the perimeter. Now let's look at some more specific formulas. And first, let's draw some shapes in. So I'm going to draw a few shapes here. I'm going to draw, and I'll name them. Let's draw a triangle. And now for any triangle, we can have, I'll draw 2 triangles here that have the same sort of setup, just look a little different. When we're working with triangles, we have a base and a height, or a base, the base side, and a height. You can measure the height vertically, right? Whether the triangle has a nice vertical edge already in it, or whether you need to draw a vertical edge to measure the height, we can measure the height of a triangle, right? Now, for triangles, the area is equal to 1/2 base times height. That's the formula for the area. The perimeter, you add up all the sides, right? So you would have to know all three sides in a triangle for perimeter. So for perimeter, if we draw a triangle, usually when we label all the sides, we label them A, B, C. The perimeter is equal to A plus B plus C, right? It's adding up all the sides. Then we have one more triangle formula, and this is for a right triangle. It has to be a right triangle. It has to have a right angle. It has to have a right angle. And we're going to put the letter C across from the right angle. And we'll put A and B here. You may have heard C called the hypotenuse. It's opposite the right angle. It has to be a right triangle. So this is a formula for right triangles. And this is A squared plus B squared is always equal to C squared for a right triangle. This is the Pythagorean theorem. For a right triangle, if you square A and you add the square of B, you get the square of the other side. That's always going to be true for right triangles, only for right triangles. So we've got a few different formulas for triangles, right? We've got how to calculate the area, we've got the perimeter, and we have a Pythagorean theorem for just for right triangles. Now, we can also have rectangles. A rectangle, well, a rectangle, if we draw one, has two measurements, a length and a width. And remember, for a rectangle, the perimeter is equal to 2 lengths plus 2 widths, right? If I add up all the sides, opposite sides are the same, right? I know the top is L and the left side is W, right? I know the other sides. And the area is length times width. And then if we have a square, in a square, all sides are even, right? We usually use the letter S for a square. I made it look a little cursive-y so I can remember it's an S and not a 5. And for a square, the perimeter, well, a square has 4 sides of the same length. So the perimeter is 4S, right? If I add up all the sides, S plus S plus S plus S. And the area is side squared. You square the side. You multiply the side by itself. Side times side, right? So that's for squares. Squares are just specific flavors of rectangles, though, right? Next, we might have a parallelogram. A parallelogram. A parallelogram has opposite sides parallel, but doesn't necessarily have 90-degree edges like a rectangle. Think of it like a rectangle you stepped on, right? It's kind of slanted. It has non-90-degree edges. But it still has some similarities. The opposite sides are still the same length. And with a parallelogram, we actually measure it similar to a triangle. We measure the height and we measure the base. And the reason we care about is because the area is base times height. The area of a parallelogram, right? It's similar to a rectangle, right? It's a rectangle you stepped on. You smushed it diagonally, right? Parallelogram is base times height for the area. And then perimeter, you would add up all the sides, right? You need to know all 4 sides for perimeter. Perimeters always add up the sides. Next, maybe we have a trapezoid. And trapezoids come in 2 flavors. The first, I always like to think of kind of like a shoe that you drew really cartoonish. And there's 3 measurements in this. There's the little base, the height, and the big base. Now, trapezoids can also be drawn like this as well, right? Notice they have 2 sides that are parallel and then 2 sides that mismatch, right? They're going opposite way. They're not going the same way like in a parallelogram, right? The opposite sides are parallel in a parallelogram, right? But here they might be mismatch, right? And same thing, there's going to be a height, a little base, and a big base. And the reason for this is because the formula is the area is equal to 1/2 of the height, and then in parentheses we have big base plus little base. And we saw this formula show up previously in our course. We have seen this formula before, right? We just might not have known it was for the trapezoid. So we've got some of our regular shapes. There's one more we want to talk about, and that is for circles. Now circles have two possible measurements. The first I am going to draw in red. From the center to the outside edge is called the radius. From the center to the outside edge is the radius. Now, the whole way across is the diameter. The whole way across is the diameter. So we have radius, which is r, and we have diameter, which we use the letter D for. Radius is from the center to the outside, and diameter is across the whole thing. Now, with a circle, we don't measure perimeter. We call it circumference. When you go around a circle, you call it circumference. And circumference has a few different formulas. There's going to be two. Circumference is either pi times the diameter, or the circumference can be equal to 2 pi times the radius. And this is because the radius relates to the diameter. I know that the diameter is always double the radius, right? If the radius is from the center to the outside, the diameter is always double the radius. So I've got two formulas for circumference, depending on whether I have the diameter or the radius. And then I have a formula for area. The area formula is area equals pi r squared. So that's for our circle. Notice you need to know how radius and diameter relate because area only has one formula. We need the radius for the area. Circumference, you can use either one though. And that's a bunch of formulas for our purposes. You'll want to familiarize yourself with this list of formulas. You want to make sure that you have them in mind, you know how they work, and we'll see some examples of these here on the next page. So let's take a look here. I will keep this page handy so we can reference back to it. Let's take a look at our problems. Rob wishes to replace the sod on a lacrosse field. Alright, lacrosse field. Alright, what shape is a lacrosse field? What shape is a sports field? It's a rectangle, right? I'm going to draw a rectangle. There's my lacrosse field. One pallet of Bethel Farm sod costs $360 and covers 480 square feet. Alright, so for $360, I get 480 square feet of coverage. If the area to be covered is a rectangle with length 360, so the length is 360 feet, and the width is 228 feet, determine A, B, and C. A, the area that needs to be covered. Well, I have a rectangle. Area of a rectangle is length times width. I always recommend writing your formula first. That way you know what you're plugging into. Length is 360. Width is 228. And I can multiply 360 times 228. So I'll take my calculator. 360 times 228 gives me 82,080. 82,080. And it's feet squared, right? It's area. So it would be feet because I started with feet, and it would be squared. So the area that needs to be covered is 82,080 feet. Now, how many pallets of sod must Rob purchase? Well, if I have to cover a total of 82,080 feet, and each pallet covers 480, well, I can take 82,080 and divide it by how much each pallet covers, right? How many pallets do I need? I can divide this, right? Divide the total by how many each pallet covers. So I'll take the total amount I need to cover and divide it by 480. Gives me 171. 171 what? Pallets, right? We're measuring pallets. So notice we just went from pallets, or we went from square footage to pallets, right? We took our total square footage to cover and divided by how much each pallet gave us to get our value. We need 171 pallets. So how many pallets of sod must Rob purchase? 171. Now, the total cost of the sod. Well, if he's buying 171 pallets and they're 360 apiece, let's see, 171 times 360. Well, I'll multiply that. Gives me 61,560. So the total cost of Rob's project would be $61,560. So I have found the cost of the sod. And think about it, if you've ever landscaped a garden, it can get quite expensive. A lacrosse field is very big. They're using very specific types of grass, right? They're not just using any type of grass. It would make sense that it would cost a hefty penny to cover. You know, this is a big area, right? 360 feet by 228 feet. That's a lot of sod to buy. Should make sense that it has a hefty price tag, right? Shouldn't be something, like, if I get 76 billion, maybe a little too hefty, right? If I get 10 bucks, probably not hefty enough, right? I can think about if the answer makes sense. So that's our first example. Notice it used rectangles, and then it asked us some conceptual questions on it. The second question, a moat surrounding a castle is 18 feet wide, and the wall of the castle is 24 feet high. So I have a wall of a castle and a moat surrounding the castle. An invading army wants to use a ladder to cross the moat and reach the top of the castle wall. How long must the ladder be? So the first thing I want to do is, what shape am I actually talking? What is going on in this picture? So I'm going to draw some things. I'm going to draw a castle. You know, I'm just going to give a quick little sketch. There's my castle wall, right? Next to that castle wall, it says is a moat. So here's my, I'll use the blue pen because it's water. There's my moat next to my castle wall, right? And my invading army wants to place a ladder, from the edge of the moat up to the top of the castle, right? They want to put a ladder to cross that moat. So a moat surrounding a castle is 18 feet wide, so the moat is 18 feet. The castle wall is 24 feet high. And I want to know how long this ladder is. Well, what shape did I draw here? What shape is this? Castle, water, ladder. It's a right triangle, isn't it? The water and the wall will meet at a 90-degree angle, right? So I can label these. Maybe I label them A, B, and C, since it's a right triangle, because I'm going to want to use the Pythagorean theorem for this question. I want to know what is C, right? I want to know what the hypotenuse is. I want to know what the ladder is. And I know my other values. Well, 24 squared plus 18 squared equals C squared. And then I'll square these values. Let's see. 24 squared, I believe, is 576. Let's see. 24 times 24 is equal to, yes, 576. Let's see. 18 squared would be 180, 260, 324, I believe. 18 times 18. Yes, 324. And that should equal C squared, right? I did my exponents first. Now, I'm still leaving C squared. I can add these two together. 324 plus 576 plus 576 gives me 900 when I add those together. And that should equal C squared. Now, we haven't really solved equations like this yet. But we know what to do here, actually. We had mentioned several chapters ago in chapter 5 that we would be taking square roots eventually. What's the opposite of squaring is square rooting. I'm going to put a square root symbol on both sides of my problem, because that will give me plain old C here. Square roots cancel out squares. They're opposites of each other, right? Square rooting and squaring are opposites. So I want to take the square root of 900. So I'll take 900 and square root it, and I get 30. So C is 30. So how long must the ladder be? 30 feet long. And I can say at least, right? Because if I bring a longer ladder, I'll be all set, right? If I'm trying to invade this castle and I bring a 40-foot ladder, I'll be fine, right? But I need to make sure I have at least 30 feet of ladder. Otherwise, it won't be big enough, right? I need at least 30 feet of ladder. So there's an example with the Pythagorean theorem. On the next page, we've got some more examples. The first one is about pizza. Victoria wishes to order a pizza. She can choose from among 3 pizza parlors in town: Little Italy, Pizza Hut, not anymore, or Owl's Nest. Let's see. So we got 3 choices. Little Italy sells a circular 16-inch diameter pizza for $15. So I'm going to write Little Italy. They have a circular pizza. The diameter is 16, and it's $15, right? Alright, so that's Little Italy. Next, we'll look Pizza Hut. They sell a round. Round is just another word for circular, right? So Pizza Hut. They have a circular pizza as well. It has a diameter of 14. These are all in inches, so we should have written inches next to both of these. And the Pizza Hut pizza is $12. And then Owl's Nest sells a square pizza that's 12 by 12. So we'll go back to red. Owl's Nest. They sell a square pizza that's the side, right? Squares have sides of 12 by 12, and it costs $10. Which pizza is the best buy? So for this, I have to do 2 things. First, I need to figure out how much pizza I get with each pizza. I need to calculate the area for each of these pizzas. Area, area, area. I'm looking for 3 areas here. I'm looking for 3 values for my areas. Now, the square one will be the easiest. So let's do the square one first. We have a square that's 12 by 12, right? So for the Owl's Nest, the area of, maybe I put a little ON next to the word area, so I remember it's for the Owl's Nest, will be S squared, which will be 12 squared, which will be 144, right? So the Owl's Nest pizza has 144 inches squared. This was inches, right? Inches squared. That's how big the Owl's Nest pizza is. Now, let's move to Pizza Hut. The area for Pizza Hut. It's a circle, right? Circle has pi r squared. So I'm going to plug in 3.14 r. I need to be careful. I know the diameter is 14. The radius is always half the diameter. So I'll use 7. Notice I put 3.14 for the pi. So let's see. 7 squared. We got to do exponents first, right? 7 times 7. Oops. Gives me 49. And then I'll multiply that by 3.14, right? I'm just plugging in my values. Gives me 153.86. So I get 153.86 inches squared. And then lastly, the area for Little Italy is also a circle, so that'll be pi r squared, right? Pi is still 3.14, but my radius of my Little Italy pizza is half of 16. That'll be 8, right? 8 squared. 8 times 8 is 64, right? Do an 8 squared first. times 3.14 gives me 200.96. So the area of the Little Italy pizza is 200.96 inches squared. So I now know how big each pizza was. Now, they don't all cost the same. If they all cost the same amount, I would buy the biggest pizza, right? But they have different prices. So I'm actually going to calculate their unit price. I'm going to calculate how many dollars per size they have. If you've ever gone grocery shopping before, you know unit price tells you how much you get of the object for what price you're paying. To calculate unit price, if we need a reminder, unit price is equal to dollars over size. You divide the dollars by the size. So, I'm going to use UP for unit price. Let's use the blue pen. We'll do unit price of, and we'll put a little ON to remember we're doing owl's nest first. So we're doing the unit price of the owl's nest. It's dollars divided by size. Dollars divided by size. $10 divided by 144. So let's see. 10 divided by 144 gives me, I get a decimal. I get 0.06944. It looks like I have a bunch of fours, right? So 0.6944. And it was dollars per size. So if I wanted to put units on it, I could put dollars. And then in the denominator of my units would be what was the size measured in? Inches squared, right? Dollars per size. That's how unit price is always done. Next, I would do the unit price of, let's go the same order we did before. We'll do Pizza Hut next. We do dollars per size. It's $12 for 153.86 square inches of pizza. I'll have to do $12 divided by 153.86 gives me, and I'm going to write 0.0, let's see, 7799. The unit will be the same, so maybe I'll just, put an arrow to say the unit's the same, because it's dollars per inch squared, right? Dollars per inch squared. And then the last unit price will be for Little Italy. Unit price for Little Italy will be $15. And the size is 200.96. $15 divided by the size. Once again, I'll punch in my calculator. $15 divided by 200.96 gives me 0.07464. And once again, it's the same units, so maybe I'll just put a little drop-down arrow. Now, I have my unit prices. Which is the smallest? Which of these numbers is the smallest? The owl's nest, right? So owl's nest has the best buy. So my actual answer is owl's nest. Which pizza is the best buy? The owl's nest pizza. It had the lowest unit price, right? Now that question had several steps. First, we calculated the size of our pizzas, right? How big were our pizzas? What was the area of our pizza? And then we recognized that since they had different costs, we needed to set up the unit price. We needed to look at the ratio of cost to size. We're trying to get the most bang for our buck, the most pizza for our cash, right? So, if these were the sizes of the pizzas available, and this was how much they cost, if I'm trying to get as much pizza as I can for the money I have, I should always go to owl's nest according to this problem. Now, obviously pizza sizes change, they might have specials. These calculations will change depending on, how prices and sizes of pizzas change at different locations, right? But you can always shop intelligently by using unit prices. Now, let's look at our next example. Our next example, it looks like we've got an upside down trapezoid with a circle cut out of the middle, right? And it says determine the shaded area of the figure below. Now notice something. The shaded area, is everything that the trapezoid contains minus what the circle contains. It's trapezoid minus circle, right? Trapezoid minus circle gives me shaded, right? Notice, that's what's going on here. If I take my trapezoid and cut out the circle, I'm left with the shaded area. So I need to find the area of, I'm going to put a little t next to the area for my trapezoid. And I know the trapezoid area is 1/2 height, big base plus little base. Now I need to ask myself, how tall is this trapezoid, right? I know the big base is 20 and the little base is 9, but I never had the height. But what's this height? That height's the same as the diameter of that circle, right? Notice, the height of the trapezoid is the same as the diameter of the circle, right? The radius of the circle was 4, right? The radius was 4 inches, so the diameter is 8 inches, right? The diameter is always twice the radius. Notice the diameter is the height. So the area of my trapezoid will be 1/2. The height is 8, because it's the diameter. The big base is 20, and the little base is 9, right? 20 and 9. So I have to do the addition first. I get 20 plus 9 gives me 29, equals 1/2 of 8. I can do that right now. That's 4, and in the parentheses I'll get 29, right? 4 times 29, well, 4 times 29 is going to give me, what, 116? Yeah, 116. So the area of the trapezoid is 116 inches squared, right? It's an area and it was measured in inches, so it would be inches squared. So that gives me the area of the trapezoid. Now let's do the area of, I'll put a little c so I know I'm doing my circle. The area of a circle is pi r squared, right? Well, let's see, pi 3.14 r. Let's see, the radius was 4, and I'll square that. So when I go to multiply, let's see, 4 squared, 4 times 4, right? That gives me 16. And then I multiply it by pi times 3.14, gives me 50.24. So the area of my circle was 50.24 inches squared. So I have my trapezoid, I have my circle. Now I can find my shaded area, right? I take the trapezoid and take away the circle. So I'll do 116 minus 50.24. 116 minus 50.24. And that's going to give me 65.76. And it'll be inches squared because all of my measurements were in inches, right? So this will be my answer. .76 inches squared. Notice I had to do a little bit of outside the box thinking to get the shaded area, right? I had to figure out, how do the circle and the trapezoid relate? How do they give me the actual answer? So we can also find shaded areas. We can play with different shapes in the same problem. Now, our last example says Marcus wishes to purchase marble flooring for his rectangular office floor, which measures 27 feet by 23 feet. The cost of the flooring, including installation, is $114 per square yard. I noticed something right away. I said feet, then yards. Those are not the same measurements, right? I will need to keep that in mind. And then part A says determine the area of Marcus's floor in square yards. So I need my measurements in yards. So the first thing I'm going to do is I need to convert each of these to yards. I have 27 feet, and I want to convert it to yards. Remember, to convert, we put our unit fractions. We want to go from feet, so we want to cancel feet, and we want to get yards. So 1 yard is 3 feet. Remember, feel free to, if you need to remind yourself of the conversions, look back at chapter 7. 1 yard is 3 feet. Well, when I multiply, I'll get 27 right in the top. Over that feet will cancel, right? 3 in the bottom, which is 9 yards, right? 27 divided by 3 is 9 yards. So notice what I did. To get from feet to yards, I divided by 3. So for my second one, 23, I'll also divide it by 3, right? If I converted 1 feet to yards, and I know I got to divide by 3, we see that's what's going to happen, right? 23 divided by 3, well, let's see. What's that going to be in yards? 23 divided by 3 gives me 7.666. All right, so it gives me a decimal, right? 7.6666667 yards, right? When I divide this out, it gives me a repeating decimal. So I have converted my feet into yards. I'm now ready to approach part A. I can determine the area of the floor in yards. His floor is a rectangle. I don't know why I'm saying his, it's me, right? Marcus is me. We're using third person. So a rectangle, right? Area equals length times width. Maybe it helps you to draw a picture. Length times width. The length is 9. The width is 7.6666667. Notice I haven't rounded yet, right? I've just been using the number as they were given. Let's see, 9 times 7.66667 gives me 69 on the dot. It works out to be a perfectly round number, 69 yards squared. When I multiply those together, I get that the floor has a square yardage. I needed everything in yards first. I need to get things in yards first. So I have 69 square yards of office space. Now, that was part A. Part B says determine the cost of the flooring. Well, each square yard costs $114, right? So if it's $114 and I have 69 square yards, well, I'll multiply those two, right? And I'll get 7,866, which would be dollars, right? We're measuring cost. So it would cost me $7,866 to refloor my office, including installation, right? Little pricey though, right? That's not exactly the cheapest project to pursue, but I can break it down with the steps, right? So notice the geometry problems, using the formulas is always a big part of them, right? Even these longer problems, a bunch of the work was using the formulas, right? Using the formulas. You might have to do a little bit of outside-the-box thinking like we did in this one, or you might need to use a little bit of knowledge of how objects work, right? We know how pizzas work. We know how food works. We know how money works. Or you might have some examples where you have, Pythagorean theorem, or maybe you have more basic examples where you're just working with the shapes. And you will see all sorts of examples on the homework. So, that brings us to the end of this section. Thanks you all for tuning in. I will see you next time.